Today we're going to go over 2025 AMC 12A question number 24. A circle of radius r is surrounded by circles of radius 1. It's just a lot of a small circle with the radius 1. Externally tangent to the central circle and sequentially tangent to each of other, as shown. Then we try to find the central circle for the radius. The radius can be written in this form, square root of a plus square root of b plus c. We just want to find this a plus b plus c. The a, b, c are integers. Could be positive, could be negative. Before we do the solution, we're going to prepare some of the knowledge. We need some of the fundamental learning point. First of all, we talk about the special right triangle, 45, 45, 90 triangle. This is also called isosceles right triangle. The side ratio is 1 to 1 to square root of 2. That means if I know the length of the leg, I want to find the hypotenuse, we just multiply by square root of 2. If I know the hypotenuse, I want to find the leg, you just divide by square root of 2. So one is finding the long one, multiply by square root of 2. Finding the smaller one, divide by square root of 2. So that's a basic knowledge about the special right triangle. The other special triangle is 30, 60, 90 triangle. The side length ratio is 1 to square root of 3 to 2. And that means the one facing the 30 degrees angle will be the shortest one. And then the hypotenuse is twice as much as this one. So the long leg multiplied by square root of 2, we get this ratio, 1 to square root of 3 to 2. We also have the other learning point, n-sided polygon. This polygon is n-sided. We know the basic formula for sum of the interior angle, n minus 2 times 180 degrees. Sum of the exterior angles is 360 degrees. That's a fix. Regardless what the n is, we always get this sum of the angles. Central angle like this, we're going to get the two radius, consecutive radius with the edge, form a smaller triangle. This central angle is AOB. That's going to be 360 divided by n. So that's obviously simple. Let's take a look at this question. We have surrounding circles of radius 1. So if I connect the center of the big circle and the smaller circle, I get the two consecutive radius of the polygon. This is a 12-sided polygon because we get 12 circles. In this case, this will be the central angle. And so this length of the radius is r, this length is 1. So this OA and OB are r plus 1. And A and B connected. The radius of the smaller circle is 1. So AB is 2. So AOB is the central angle, will be 360 divided by 12. You got a 30 degrees right here. This is 30 degrees, okay, for the central angle, special angle. All right, and OAB, the base angle becomes 75 degrees because 180 minus 30 divided by 2, these two base angles are the same. So you get this is 75 degrees. Okay, certainly this angle, all these are congruent. So this angle is 75 degrees as well. So now we get connecting OA and OB, OCOD. There's a 4 consecutive radius of the 12-sided polygon, AOB, BOC, COD. They're all 30 degrees. So these are 30 degrees, these are 30 degrees, these are 30 degrees. All these are 30 degrees. So together they form a right angle. we just put a 3 smaller triangle together, we get a right angle. So OA also equal to OD, we get 45, 45 isosceles special right triangle right here. And OAB, 75 degrees right here. Okay, and AOD, this is AOD is 90 degrees because we get a 30 degrees together. So therefore, this is 45. So 45 degrees right here. And this one is 75 degrees. So the difference of them is 30 degrees. And that means this is a BAE or BAD is 30 degrees. On the other hand, we get OA equal to OD equal to R plus 1. So isosceles right triangle, the hypotenuse is multiplied by square root 2 from the leg, R plus 1. From here, as we mentioned, this is going to be 30 degrees angle. This is a 30, 60, 90 special triangle with the side length of the shorter leg is 1, hypotenuse is 2, so we can get an AE equal to square root of 3. Okay, the same thing over here, that's exactly congruent to this one. DF also equal to square root 3. This is BC parallel to AD, so EF is 2. So we draw, basically, from here we gotta draw the BE and the CF perpendicular to AD. We form these two congruent right triangle. ABE is 30, 60, 90 triangle, and a B is 1. We get an AE equal to square root 3. DF on the other side is also equal to square root 3. EF equal to 2. That's equal to BC, the side length of the 12-sided polygon. So I can find AD equal to 2 square root 3 plus 2. This is one way I can find this length, AD. I find this one successfully in one way to do it. And also we have the other way to get the length of AD so that we can set up the equation to figure out our variable, the radius of the large circle, R. So let's do the other way, okay? First of all, we get AD equal to square root 2 R plus 1 because that's a special right triangle for the hypotenuse. The other way we get it is going to be 2 times square root of 3 because this is square root 3, this is square root 3, this is a 2, so you add them together. So from here, we'll get they are equal. So I multiply by square root 2 on both sides in order to solve this R easily. So we can get a 2 times R plus 1 equal to 2 times square root of 6 because square root 3 times square root 2. This is 2 square root of 2, and I'm going to divide by 2. You're going to figure out the answer. R plus 1 equal to square root of 6 plus square root of 2. And then you simply just subtract 1 on both sides. We get the radius, which is square root of 6 plus square root of 2 minus 1. So we get the radius right away. So we get the answer. The sum of the ABC is 6 plus 2 plus negative 1, which is 7. So the answer is C.